The directions say to find the radius of convergence and interval of convergence of the series. Let's take a look at example 1. Suppose we have the summation from n equal 1 to infinity of negative 1 to the n times x to the n. A sub n is equal to negative 1 to the n times x to the n. To find a sub n plus 1, I'm going to replace n with n plus 1. And so a sub n plus 1 is negative 1 to the n plus 1 times n plus 1 times x to the n plus 1. And breaking this apart, we get negative 1 to the n times negative 1 times n plus 1 times x to the n times x. Plugging this in, we get the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n, applying the ratio test, which is equal to the limit as n goes to infinity of the absolute value of negative 1 to the n times negative 1 times n plus 1 times x to the n times x, all divided by negative 1 to the n times x to the n. So the x to the n's are going to cancel, and so are the negative 1 to the n's. And remember a couple of things. The absolute value of negative 1 is equal to 1, and if we look at the limit as n goes to infinity of n plus 1 over n, this is the limit. As n goes to infinity, if I split this fraction up, I get 1 plus 1 over n. And as n goes to infinity, 1 over n is going to approach 0. And so this is 1. And so we get the limit as n goes to infinity of n plus 1 over n times the absolute value of x, right here, and that's the absolute value of x. By the ratio test, this series converges when the absolute value of x is less than 1, or when x is greater than negative 1 and less than 1. And the test is inconclusive when the absolute value of x is 1. And this is why we have to test endpoints. Now, remember, the absolute value of x is 1 when x is 1 or x is negative 1, right here. So when x is 1, we have the summation from n equal 1 to infinity of negative 1 to the n times n. And this series diverges by the test for divergence. And when x is negative 1, we have the summation from n equal 1 to infinity of just n. And this series will also diverge by the test for divergence. And so what does all that mean? The interval of convergence is the open interval from negative 1 to 1. The radius of convergence is 1. And with that, let's take a look at example 2. Suppose we have the summation from n equals 0 to infinity of x to the n over n factorial. And think ratio test again. My a sub n is x to the n over n factorial. A sub n plus 1 is x to the n plus 1 over n plus 1 factorial, which is x to the n times x over n plus 1 times n factorial. Now we get to apply the ratio test. And so we're going to look at the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. But that's the limit as n goes to infinity of x to the n times x over n plus 1 times n factorial. And when you divide by a sub n, you essentially are going to multiply by the reciprocal of a sub n. So we're going to take that and multiply by n factorial over x to the n, and that's all in absolute values. Now look what happened. The x to the n's cancel, and so do the n factorials. And we get the limit as n goes to infinity of the absolute value of x over n plus 1. And that's 0 for all x. And remember, 0 is less than 1. So the interval of convergence will be negative infinity to infinity. It's going to converge for all real numbers. The radius of convergence is going to essentially be infinity. That's example 2. Let's take a look at example 3. Suppose we have the summation from n equal 1 to infinity of x to the n over n to the fourth times 4 to the n. So this is a perfect one where I can apply the root test. Now, one thing I want you to note, the limit as n goes to infinity of n to the 4 over n is equal to 1. And we can go over this at the end of this video. That's totally fine. Now, a sub n is x to the n over n to the fourth times 4 to the n. This is a perfect one to apply the root test. So we're going to look at the limit as n goes to infinity of the nth root of the absolute value of a sub n. But this is the limit as n goes to infinity of the nth root of the absolute value of x to the n over n to the fourth times 4 to the n. So this is the limit as n goes to infinity of the absolute value of x divided by n to the 4 over n times 4. But as n goes to infinity, n to the 4 over n goes to 1. And so this is the absolute value of x over 4. From the root test, this series converges when the absolute value of x over 4 is less than 1. Another way to say that is that x is greater than negative 4 and less than 4. The test is inconclusive when the absolute value of x over 4 is 1. And equivalently, we can say x is 4 or negative 4. So that's right here. So the only way the absolute value of x over 4 is 1 is for when x is 4 or it's negative 4. And those are the endpoints we need to check. For x is 4, we have the summation from n equal 1 to infinity of 1 over n to the fourth. And this series will converge by p series. P is equal to 4, which is greater than 1. And for x is negative 4, we get negative 1 to the n over n to the fourth. So I want to make sure we understand where I'm plugging this in. I'm replacing x with 4 in this power series. And 4 to the n over 4 to the n reduces to 1. And so that's why I'm just left with 1 over n to the fourth. And then for x is negative 4, we're left with the summation from n equal 1 to infinity of negative 1 to the n over n to the fourth. And this series will converge by the alternating series test. And double check with your instructor as to how much work your instructor wants to see, or can you just state that for this particular kind of problem. Now, the interval of convergence is the closed interval from negative 4 to 4. The radius of convergence is 4. Now, here's a claim. If I take the limit as n goes to infinity of n to the 4 over n, I get 1. And what I'm going to do is I'm going to let f of x equal x to the 4 over x. And we're going to look at the limit as x goes to infinity of x to the 4 over x. Okay. Now, here's how this works. Set y equal to x to the 4 over x. Take the natural log of both sides. So natural log of y is equal to natural log of x to the 4 over x, which is 4 over x natural log of x. Okay. Now, the limit as x goes to infinity of, I'm going to call that 4 natural log of x over x equals. Now, if you plug in infinity, you get infinity over infinity. And so by L'Hopital's rule, this is the limit as x goes to infinity of, I get 4 times 1 over x divided by 1, right? The derivative of the numerator is 4 times 1 over x. The derivative of the denominator is 1. And so this is equal to 0. And so therefore the limit as x goes to infinity of natural log of y is equal to 0. So the limit as x goes to infinity of y is e to the 0, which is equal to 1. But y is x to the 4 over x. Y is x to the 4 over x. And so the limit as x goes to infinity of x to the 4 over x is 1, right here. And so we can thus conclude that the limit as n goes to infinity of n to the 4 over n must also be 1. And that's verifying what I used in one of the earlier examples. Okay, that'll conclude this video. We will make another video that involves power series. So in this video, we did 3 examples. Thank you.